I hope you liked my earlier videos. Today I am going to continue ahead with the same topic, but few more concepts which are very important from this chapter called as current electricity. And it goes like this. Since we know so far what is V, I and R. V is potential difference, I is electric current, and R represents resistance. So far we did and we have done with regard to all this. Okay. Let's move ahead and discuss something with regard to the new topic. And what is the new topic we'll be discussing about? So, new topic what we'll be discussing about is something called as very important concept, and it's a law called as Ohm's law. Now, what is this Ohm's law and how this can be applied at many different places? So, basically Ohm's law is nothing else but it has shown the relation between two very important terms. The two very important terms here is electric current and potential difference, and it has shown the relation between I and V. What is the relation shown is that the electric current flowing across the circuit is always directly proportional to the potential difference applied across the conductor. So more the potential difference, more will be the electric current in a given conductor. And how do we verify this Ohm's law? How will we verify? So today I am going to show you the diagram of verification of Ohm's law. Okay. So what are the different components you require for this particular diagram? Let's say that we have a battery, a plug key, a rheostat, and in the series we connect the ammeter. So this is my ammeter connected with, let's say this symbol represents the resistance, and it comes back to this. This is my rheostat, plug key, battery. This is positive terminal, this is negative terminal, ammeter, and this is my resistance. Ammeter is always connected in series, whereas the potential difference is connected in parallel over here. So this is my potential difference, that is the voltmeter, and this is my ammeter. Very important to notice that this ammeter has two pins. One is the positive and the other one is the negative. Positive should always be connected to the positive of the battery, and the negative of this ammeter should be connected back to the negative of the battery. Whereas the voltmeter has a positive negative. This is also a meter, so its positive indirectly goes to the positive of the battery, and the negative via connections goes back to the negative of the battery. Any meter, if it's a voltmeter or it's ammeter, it's a multimeter, the connection should be always in such a way that the positive should go to the positive, the negative should go to the negative of the battery, and this is how your connection gets completed. So now what will happen over here? The ammeter, which looks something like this. Can you see it's A written inside the ammeter? Now this ammeter will give us the reading of electric current flowing inside the circuit. So we will measure the electric current across the whole circuit, and we measure the potential difference. This potential difference is measured using the instrument called as voltmeter, and voltmeter looks something like this. Now easily it's possible for you to differentiate between the voltmeter and ammeter. At the place of ammeter you can use milliammeter also, which measures the small current. I'll give you one question. Try out at home. There is one more instrument which can measure very feeble current inside the circuit. It's very small current flowing inside the circuit. This may help you in the higher grade, but just rack your brain and come up with the answer. You move ahead. So this voltmeter will measure the potential difference, and this ammeter will measure the electric current, which is I. So what through this experiment it has been noticed is that you keep on varying the resistance across the circuit using a rheostat. A rheostat is a kind of a device which can be used as a current divider or it can be used as a potential divider. Here we are using this rheostat as a current divider, and a rheostat looks something like this. Did you notice that? So there is a jockey about that. If you keep on moving that jockey, you can vary the current across the circuit, keeping this particular power supply's voltage constant. So for different values of I, you will measure the electric current inside the ammeter and you will measure the potential difference across this for different readings. And you will notice that if you find the relation between I and V, you will come to know that my I will be directly proportional to V. So as the current, as the potential difference increases, the electric current across the circuit will also increase. And this is how the Ohm's law has been verified through the experimental method. So basically, if they ask you what is Ohm's law or what is the statement, what is the definition, the Ohm's law's definition is that so long the physical condition of a given conductor remains the same. That means the physical state, there is no change in the state. Also, the temperature across the given conductor should be constant. Only these two conditions are satisfied. Then, the current flowing across the circuit will be always directly proportional to the potential difference applied across the conductor. So, this is what verification of Ohm's law is all about. But mathematically, I directly proportional to V can be written as V directly proportional to I also, if I consider that way. Since there is a proportionality sign over here, this proportionality sign we can change into the equality, but we have to remove this and we have to add the constant of proportionality. So V is equals to Ri, and this R is called as constant of proportionality. Now, when I say that this R is constant of proportionality, this constant of proportionality R is actually called as resistance. So this R is called as resistance. So if we look at this particular equation only, that is V equals to IR, can be written as V equals to IR also. So we come to know that V upon I is equals to R. That means the ratio of potential difference and the electric current across a given circuit will be always a constant. And this constant is called as resistance. Now, actually if you look into this, I directly proportional to V, this is actually the Ohm's law. But certain times, if we ask the student what is Ohm's law, they come up with the equation V equals to Ri, or they may say V equals to IR. Actually V equals to IR is not Ohm's law. V equals to IR is something where you come to know about concept of resistance, which we did in our first lecture of current electricity, concept of resistance. So this is resistance which is constant and is constant for a given conductor. But this particular resistance can change. If the temperature is changing, the resistance can change. So there are certain factors on which the resistance, that is the obstruction offered for the electrons, may vary. But it depends on certain factors. So we will see what are the different factors on which the resistance depends. But before we move ahead, let's see what is the unit we get for resistance. So my unit for resistance is, this is V, which is measured in volt, and the current is measured in ampere. So volt per ampere, or also written as omega. So volt per ampere or omega is the SI unit of resistance. Now, since you go through so many different formulas all the time in your studies, I make certain method. My name is Tanveer. So if I write the name as Tanveer, Tanvir, and you divide into two parts, the 10 itself become the part of a math when you learn in trigonometry ratios, tangent, and this VIR, if I put a equal to sign over here, V equals to IR. That means this V equals to IR is nothing else but the concept of resistance what we have done so far. Or actually you know now one formula, V equals to IR, which will help you a lot. Let's move ahead and let's see what are the different factors on which this resistance depends. Alright, so let's see what are the factors on which the resistance depends. So factors on which the resistance depend. The first thing is the resistance of any given conductor depends on the length, and the relation is that the resistance is directly proportional to the length of the conductor. That means if the length increases, the resistance of a given conductor will also increase. So my first factor. Second factor, resistance depends on the area of cross section. So when I say the resistance depends, it depends on area of cross section of a wire, or it is also called as thickness of the wire. So how does it depend? Let's say I take one wire, and for the same wire I increase the cross section area of the wire. Then this particular resistance will be inversely proportional to such area of cross section. Because when the area of cross section, what is the meaning of cross section? I'll just give you a simple example. If you look at this particular chalk, this is called as the surface area, but if you look at in front, you will see only this much part, and this is called as cross sectional area. So if you change the cross sectional area of this to double of this, then the electrons get more space to move out. In that sense, there will be less resistance because now electrons can move freely for that particular volume. So here resistance is inversely proportional to area of cross section of a wire. Okay, so if I combine these two equations, I get R directly proportional to L and inversely proportional to A. If we look into the area of cross section, what is the geometrical figure do you notice over here? It's circle. So what is the area of circle? Area of circle is pi r square. You can use that also. If I remove this constant of proportionality, then this particular constant of proportionality is written as rho, and it is R equals to rho L by A. Since this constant of proportionality we have added over here, this constant of proportionality called as resistivity. So this constant of proportionality is called as resistivity. Now looking at this particular formula, whenever you know any given formula, you can easily calculate and find their SI unit or MKS or CGS easily. So if I make a subject of the formula of rho, then how do we get this? It's R into A upon L equals to rho, resistivity. Now let's substitute all the units what we know, and we come up to the unit SI unit for rho. Resistance is measured in ohm, area is measured in meter square, and L is measured in meter. So this and this gets cancelled, equals to rho. Therefore SI unit of resistivity. Now If I am talking with regard to resistivity, I am talking about rho, and this resistivity unit is ohm meter. So the factors on which resistance depend is these two factors, but there are two more factors. I didn't explain that because we were planning to find out the resistivity and the SI unit. So what are the other two factors on which the resistance depends? Okay, so let's look at the third factor. It depends on the temperature of a wire. Let's say if the temperature of the wire is increasing, then the resistance will also increase. So resistance is directly proportional to the temperature of the wire. Increase in the temperature of the wire, there will be increase in the resistance. Increase in resistance increases the heat energy. And due to that increasing heat energy, the wires melt. And the fourth factor on which the resistance depends is the nature of the conductor. What do I mean to say? I mean to say that good conductors will have less resistance because they have more free electrons, they can move easily. They have large space for the electrons to move. So, a good conductor will have less resistance. And let me tell you, I think I have already explained you. I have given the assignment. There are certain conductors which have actually zero resistance at low temperature, and they are called as superconductors. I suppose if you work on this and find some information upon superconductors, you have enormous knowledge keep on gathering for your future. So find some information about superconductors and it will help. So we are done with the factors on which the resistance depends. So we are done with very two important concepts. One was the Ohm's law and the other one is the factors on which the resistance depends. In the next class we will see resistivity and some numericals based on resistance. Subscribe, like, and please give the comment. If there are any changes, any improvement needed, definitely I will follow. Thank you. Take care.